Now that we know a little bit more about points, let's try to look at the distance between 2 points. So let's say I have 2 points and they can be anywhere on the plane. I'm going to say that this one is x1, y1, and I'm going to call this one x2, y2. What I'm really looking for is the length of this line segment right here. However, I'm going to go ahead and draw the rest of this triangle. Down here, this bottom edge, the length of it is going to be x2 minus x1, using just the distance between 2 numbers. The vertical side will be the top point minus the bottom point, y2 minus y1. Well, we do know the Pythagorean theorem. I'm going to call this side d for distance. The Pythagorean theorem says that the hypotenuse squared is equal to each of the legs squared. So x2 minus x1 squared plus y2 minus y1 squared. We can take the square root of both sides, and we don't have to worry about the negative square root here since distance is always positive. And we get this equation. The distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. And this right here is our actual formula for distance. So let's look at a few examples using this. I want to know the distance between these 2 points. And just a reminder, that's the square root of x2 minus x1 squared plus y2 minus y1 squared. So here, x2 is 4 minus negative 3, or plus 3, plus y2 is 1, and y1 is 2. 4 plus 3 is 7, and 1 minus 2 is negative 1. 7 squared is 49, and 1 squared is 1, so I get the square root of 50. However, we can simplify this. 50 is the same thing as 25 times 2, and we know that the square root of 25 is 5, so this is 5 root 2. For the next example, is 8 over 9 or 1 negative 2 closer to the point 5, 3? Let's start by finding the distance between 8 over 9 and 5, or 8, 9 and 5, 3. So we have x2, which is 5, minus x1, which is 8, squared, plus y2, which is 3, minus y1, which is 9. 5 minus 8 is negative 3, and 3 minus 9 is negative 6. So that's 9 plus 36, which gives me the square root of 45. What about my other point? 1, negative 2, and 5, 3. So x2 is 5, minus x1, which is 1, plus y2 is 3, minus negative 2. That gives me 4 squared plus 3 plus 2 is 5, so 5 squared. The square root of 16 plus 25, which is 41. So the point 1, negative 2 is actually closer to 5, 3. The next thing I want to look at is the midpoint between 2 points. So once again, I have 2 points, x1, y1, and x2, y2. So I draw the segment between them, and I want to know where the midpoint of that segment is. And the formula for that is we're going to average the x's, comma, average the y's. So let's look at an example of this. Negative 4, 2, and 3, negative 5. So I'm going to add up the x's, negative 4 plus 3, divide by 2, Add up the y's. 2 plus negative 5 divided by 2. Negative 4 plus 3 is negative 1, and 2 plus negative 5 is negative 3. So the midpoint here is minus 1/2 minus 3/2.